So to demonstrate the success criteria and features have all been met of my NEA, I've created 2 Scratch projects utilising some of these features, and I'm going to be running my Scratch compiler on these projects and showing that these features are working. Firstly, I've gone through a table in my success criteria and highlighted in pink features that I'll demonstrate with this first project, and green features that I'll demonstrate with the second project. You can see I've also, my success criteria linked to features, so I've then also done the same highlighting on my features table. So first I'll show you the first project. So when I put this block back in, and now run the project, you can see I'm demonstrating the say and think blocks because it's saying and thinking, and ask with the ask block. And then I'm also demonstrating sound as it's playing sounds of various pitches, sensing blocks like the ask, distance to, backdrop of, days since, current year, which it said at the start. So I'm demonstrating the sensing blocks, sound, all these things. So that will then check off from the features. It will demonstrate sound here. It will demonstrate say, think, and ask. And it will demonstrate functionality of all not mentioned sensing blocks, therefore, if my compiler compiles this. Then I'm showing the layer order by being able to press keys to change a layer, left to go to back, right to go to front, and up and down to move forwards and backwards layers, and change the backdrop. So therefore, if this works, I'll be demonstrating layer order, and I'll be demonstrating stage, which is the background. Also, obviously, console interactivity, because say, think, and ask will be in the console for simplicity. So I'll now save this, and let's export this project. I think I need to remove the previous one first. So let's download the project. You can see it downloaded. Now I need to remove my directory from the previous recording. And now let's run the compiler. I'm going to remove this block because it's being annoying, making the noise. That should stop now. So now it's running the compiler. It does take a long time on my weak laptop whilst recording. This obviously compiling these projects. Oh, there we go, it's done. So now let's run the compiled result. And we can see that the sound is working. It's playing in various pitches. The timer's obviously working to play sound with the timer. The say and think blocks have worked, and the ask block works. It's waiting for my input. I'm going to enter hello. And now the say and think blocks are printing their output. One of them being the distance to the mouse pointer, which you can see is correctly working, goes to near 0 when I put the mouse on the Scratch cat. Now I can press left to go to the back layer, right to go to the front layer, and then I can press up to go forwards layers and down to go back layers. You can see it's all working. Yeah, cool. Okay, now the next project. So I'll close this terminal. Let's have a look at the next project. So yeah, I've demonstrated all of the ones in purple and mentioned how. Now this next project will demonstrate, well, this project has also demonstrated sprites because I'm using various sprites in this project, so I can check that off being demonstrated. Code execution. I'm executing this code, these code blocks, and this blocks all simultaneously, so I'd argue code execution has been demonstrated to work correctly. And a few of the blocks have been demonstrated. And the CLI to run the compiler has been demonstrated. But this next project, which I'll show you first and then discuss which success criteria it fulfills, this is hexagonal noughts and crosses. So you can see I have a hexagonal grid, and the first person goes once, and then the subsequent turns you go 2 at a time. And the goal is to try and make a line of 6 in a row. So you can see I've not blocked this. So now this player can place their 2 in a row and get 6 in a row, and it will highlight it in blue. This project was just a bit of fun with Scratch, and I can show the compiler compiling this. One thing I have done to demonstrate the full complexity of my compiler is if online is false, setting the resolution much larger. So my compiler will actually provide a good benefit setting it to a much larger resolution. You can see if I do if not false, so it tries the high resolution on Scratch, it will just, if I try like, I don't know, blank equals 50, which is false, it will try the large resolution on Scratch, and it will take a very long time, and it will just be incredibly slow. So this demonstrates one of the needs for the compiler to try these large resolutions. So let's put that back to how it was. Let's save it. And then also, if you're interested, this is not a paper I wrote, but this discusses some methods for hexagonal grids. I just constructed these two basis vectors, and then everything could be expressed as multiples of these basis vectors, along with some rounding. It's basically a 3D plane. Then, an angle is a nice way to have those basis vectors. If you have a third one, not that you need a third one. Anyway, so if this project works, I will demonstrate sprites, because yet again it's using sprites. So this will be demonstrated. Code execution, obviously it has to demonstrate code. Most blocks out of my features, you can see operators blocks, all these green blocks it's using. Control blocks, all these yellow blocks it's using. Events, I've used a lot of event blocks in the other projects. I've actually demonstrated these more in this project. So those are already demonstrated. Motion, I'm using motion blocks mainly to go to various positions in this project. Although in my testing and development, I demonstrated other motion blocks. Sound was demonstrated in the other project. Variables and lists. So I'm using a massive amount of variables, and I'm using various lists to store which tiles have been placed and which are in the winning check to create a line. You can see I'm using these lists here, and in these blocks to check the win condition, I'm constructing a list checking the lines. So variables and lists are used. Custom blocks. So I've created quite an extensive amount of custom blocks in this project. So if this compiles successfully, I'll verify custom blocks. And then clones. This project is creating clones because there's only one sprite, yet I'm rendering all these hexagons by moving it around and creating clones of itself. So clones it would also demonstrate, and then costumes. These hexagons switch to various costumes. So by this project compiling successfully, I'll demonstrate costumes. And then sprite properties, size and position. I'm setting them to the correct size to scale and moving them to the correct position. So if this project works, therefore, all of these features will be demonstrated. And the command line interface to run the compiler I've already demonstrated. So all that's left to do then is run my compiler on this project. First, I'll download the project. You can see it's in download/hex.sb3. Now let's run my compiler. So Scratch compiler download / what was it called, hex.sb3, and I'm going to make the directory hex. So now I will run the compiler. It will run slowly yet again because I'm running the recording simultaneously, which I might check actually that recording is all going good. Yeah, it's running quite slowly. This project was a lot of fun to make actually. Yeah, the maths for the hexagonal grid was interesting with the plane interpretation, although really it's just two basis vectors and a bit of rounding. Rounding obviously is a little bit clever because of the various angles and hexagon. Anyway, let's go into this directory and let's run the project. And you can see we have a full hexagonal grid spanning the full screen, so demonstrating the uses of the compiler in the performance improvements. In Scratch, this was taking a while. When it tried to do the higher resolution, it's instant with this. And just like before, you can play noughts and crosses. So I can place a red here, and then I can place two blues, and then it is red's turn. It's a little bit slow because I'm running the recording software. And then it's red's turn, and then when I get a line, so I'm just going to try and construct a line, then someone will win. So now blue should be able to win. And then you see blue's marked as 1, and nothing more can be placed. So the game is working compiled. Brilliant. So that's everything demonstrated. Thank you.